Friends, in this video, let's see how to solve LVQ, that is learning vector quantization problems. So here we have given some 5 vectors and divided those 5 vectors having their respective classes. So now the first step what we have to do is the first 2 vectors should be taken as reference vectors and the rest 3 are taken as inputs. So reference weight vectors. So our first weight vector will be this. So and our second weight vector is this. And now we'll take the learning rate alpha 0.1. So now we are going to perform this LVQ for the rest 3 vectors. So now this will be our first vector, this will be our second vector, and this will be our third vector. And here we are given the classes of each vector. Let's consider the class of a particular vector as its target value. So now let's find the Euclidean distance of first vector. So our first vector is 0001. So Euclidean distance with the W1 gives D1 and with the W2 gives D2, and we have to compare both D1 and D2 and see which is minimum. So let's do that. So let's find D1. So D1 will be 0 minus 0 square plus 0 minus 0 square plus 1 minus 0 square plus 1 minus 1 square. This will give us 0, 0, 1, 0. So we'll get 1. And now find D2. 2 is 1 minus 0 square and 0 minus 0 square and 0 minus 0 square and 0 minus 1 square. This gives 1, 0, 0 and 1. So 1 plus 1, 2. When we compare D1 and D2, D1 is 1 and D2 is 2. So D1 is minimum. D1 is minimum. So let's this be in the form of dj. So the value of j here is 1. And as we have considered the class value as our target value before, so the target value of the first vector is 2. So let t is equal to 2. Here we have achieved the condition j is not equal to t. So now we have to update the weight. In this learning vector quantization, we have to update the weight for the conditions j not equal to t and for the condition j equal to t. For both the conditions we have to update the weight. But there is a slight difference in the formula which we use for updating the weights for the condition j not equal to t and for the condition j equal to t. Here we have achieved the condition j not equal to t. Means in this circumstance we have to use the weight updation formula as the new weight. The new weight is equal to our old weight minus our learning weight into our x part in our vector and the old weight. So, and also we have to update the part in which we got the minimum value. Since D1 is minimum, we will be updating the weight vector W1. So updating the weight vector W1, let's update the 0. So our old weight is 0 minus our alpha is 0.5 and our x is 0 and also our old weight is 0. So this gives us 0. Now let's update this 0. The 0 minus alpha 0.5 or x2 0 again and our old weight 0. This also gives 0. And let's update 1. So our old weight is 1, learning vector 0.5 and x3 is 0 and old weight is 1. So sorry, our alpha is 0.1, right? Yeah. Zero point one. So this becomes 1 plus 0.1, that is 1.1. And the fourth is 1. Let's update the weight 1. Whole minus alpha into our old x4 minus whole weight, that is we'll get 1. This becomes 0. So our new weight becomes W1 is 0, 0, 1.11 and W2 is 1,000. If we written in the matrix form, our overall weight will become 0, 0, 1.11, 1,000. This Euclidean distancing will be done in coherence and formulation also. And I told you, right, we have to update the weight for both the conditions j not equal to 10, j equal to t. So for j not equal to t, this is a formula for updating the weight. In the case in which if we get j equal to t, then we simply remove this minus symbol and provide plus. So this will be the formula for updating the weight if we achieve the condition j equal to t. So now let's use this weight and perform D1 and achieve D1 and D2 for the second input, and let's see. So our new weight is 0, 0, 1.11 and 1,000. Our H2 and that means our second vector is 1100. So double 1, 00. So yeah, now let's find D1. D1, 0 minus 1 square and 0 minus 1 square and 1.1 minus 0 square, 1 minus 0 square. So this gives 1 plus 1 plus 1.21 plus 1. So 4.21 and D2 1 minus 1 0 0 minus 1 1 1 square 1 and 0 minus 0 0 square 0 and 0 minus 0 0. This gives us 1. So D2 is minimum That means our j is equal to 2. Let's see the class of second thing is 1. So our j is equal to 2, but our target is equal to 1. So we achieve the condition j not equal to t. If j not equal to t, we have to use a formula which we have used for the previous input for updating the weights. So since d2 is minimum, we will be updating the second vector of our weight. So let's update this one. So our old weight is 1 minus alpha is 0.1 and our x1 is 1 minus our old weight is 1. So this gives us, this becomes 0 and now let's update 0. Old weight 0 minus 0.1 into or x2 is 1, 1 minus old weight 0. So this becomes minus 0.1. Let's update this. Old weight 0 minus alpha 0.1 into x3 is 0. 0 minus old weight is 0. 0. Let's update this. Old weight 0 minus 0.1 into x4 is 0. So 0 minus 0 becomes 0. So our new weight is 0, 0, 1.11 and 1 minus 0.1, 0, 0. Now check for the third input. So our third input is 0,110. So and our obtained weight is updated weight 0, 0, 1.11. 1.11 and 1 minus 0.1, 0, 0. So yeah, now let's find D1, 0 minus 0 square plus 0 minus 1 square plus 1.1 minus 1 square plus 1 minus 0 square. So this gives 0 plus 1 and 1 plus 0.01 plus 1. So it's 2.01. And D2 1 minus 0 and minus 0.1 minus 1 and 0 minus 1 and 0 minus 0, 0. So 1, this becomes minus 1.1, that is plus 1.21 and 1. So this gives 3.21. So 2.01 is minimum. So D1 is minimum and our J value is 1. Let's see the class value. Class value is 1. So our target value is 1. And so we have achieved J is equal to T condition. If J is equal to T, for weight updation, the formula that we should use is old weight plus alpha into x minus old weight. So now, since D1 is minimum, let's update the first vector of our weight and using this formula. Let's update 0. Wall weight is 0 plus alpha 0.1 and our x1 is 0. 0 minus 0, it becomes 0. And let's update this 0. So 0 plus alpha 0.1 into our x2 is 1 minus 0. This gives 0.1. And now let's update 1.1. 1.1 plus alpha 0.1 into x3 is 1. 1 minus 1.1, that is 1.1. And it gives minus 0.1. 1.1 minus 0.01, that is 1.09. And now let's update this one. Wall weight 1 plus alpha 0.1 into our x4 is 0. 0 minus wall weight 1. So 1 minus 0.1, 0.9. So weight now is 0, 0.1, 1.09 and 0.9. 1 minus 0.1, 0, 0. So with this we have completed the first iteration. So perform as many number of epochs which you have been asked in the question. That's the stopping condition. So if you have been asked for one epoch, do till now and stop it. And if you have been asked for two epochs, using this way, continue to start the second epoch, taking again the first input and second input and third input. That is how, and you have to perform if you have been asked for more than one epoch. And this is all about LVQ. Thank you.